Shall we start? Yeah? All right. Hi, everyone. Thanks for coming here. I appreciate it. My name is Christina, and I'm here to talk to you guys about design patterns in game development. But before we go into that, who the heck am I, right? So I'm a teacher here at Code for All. I've been a teacher here for about 4 or 5 years, something like that. That was the coolest teacher photo that I could find of myself. I am a mother to an incredible 10-year-old, almost 11-year-old. She's just as geeky and awesome as I ever dreamed. And I like to do doodles in my free time. I'm a digital artist, mostly cartoony stuff. And also, I am a wannabe game developer. It's something that I do as a hobby in my part-time, in my free time. But more importantly for this talk, I don't believe in design patterns. So thanks for coming, everyone. It was really nice having you guys here. No, okay, so what do I mean I don't believe in design patterns? How could I be a teacher for almost 5 years, and I like programming, and I like making games, and I've invited you guys here today to talk about design patterns, and then I come out with something like this? So a little bit of a story time first, just so you can understand where I'm coming from, okay? So a few years back, I really wanted to learn how to make games. In fact, when I learned programming for the first time, I always said it was a dream of mine to make games. I've always wanted to make video games. So I was playing around with something that's called Canvas API, which is basically something that you can use in JavaScript that allows you to draw images on a web page. So you can draw images, but then you can also create cool animations, and then from animations, you can create little web games. And I was talking to a colleague of mine over lunch, and he talked about how when he was a student, he had started making Space Invaders, and how he never really got around to finishing it because he didn't have enough time. It was the Games Week. I don't know if anyone here... No. Okay, yeah. Never mind.
I played Games this week.
You played Games Week? Okay. Games this week. Cool. Awesome. And he never got around to finishing. He didn't have enough time, and I'm a little bit competitive and a bit of an asshole, and I thought, well, if you can finish it, I'm going to try and do it today, in one day. So I ran back to work, I looked up what are the game mechanics for this, and I got about making a really lame, janky kind of version of Space Invaders, but it was playable, it was something, right? And I showed it off to my work colleague immediately. And then over the week, I decided to work on the mechanics a little bit more, and I had something that was actually stable, that was worth showing off. And a boss of mine here at the company actually said, why don't we put that on our site? Our would-be students will be able to click on a little icon that says arcade, and they can play it while they're waiting to do the bootcamp. And I was like, oh, such an honor. Oh my goodness, this is amazing. And then I started to panic, because I thought about all of the bad code that I wrote to finish it in one day and to finish it in 1 week. And I thought, my boss is going to review this, and it's going to be on a public repository. And I said to him, that sounds amazing. Thank you so much. Just give me a week to refactor it, okay? And then it would be about a year before it actually made it onto the site. And I wasn't refactoring it for the entire year. That would be insane, right? But I did restart about 4 times. What would happen is I would sit down and I think, okay, I'm just gonna clean this up a little bit. And then I realized the code is too spaghetti. I have to start over. Okay. Then I'll spend a couple of days making it perfect, and then I would watch a YouTube video or I'd read an article about an even better way of writing code, and I thought, oh, the thing that I wrote was so lame. Hold on, I have to go and start over from scratch. So then I did the second refactor, and then I watch another video on YouTube or read another article, and I realized there's an even better way to do collision detection, and then I would go back and refactor it. And this happened several times, and I implemented things that didn't even make sense to implement in such a small game. I basically went from one bad implementation to another. But after a year, I had something that I could put publicly. It went on the site. I was super proud of myself. What did I gain from this year of overly refactoring, of redoing my code over and over again? Honestly, not a whole lot. I wish I could say I learned so much and I memorized all of those cool things, but I couldn't begin to tell you what I even implemented back then. And I'm sure if I opened it up now, I would probably feel a little bit like, oh, there's an even better way to do this, Christina, come on. Where I did start to gain from this was when, after the fact, I decided I'm going to keep making mini games. I like making games. I'm going to clone Pac-Man. I'm going to do Minesweeper. I'm going to do some infinite runners. And even though mechanically they were a little bit different from each other, I started to notice there was a lot of things in common between them all. The way that I would divide the update and the render functions, the way I would handle input from the user, collision detection was pretty much the same between all the games. It was AABB. So I figured, great, I'll make a template that I can copy, and then when I want to make a new game, I'll just copy the template and change the different things. I made a tiny library of all of the functions that I was using a bunch of times, especially all those math functions that sometimes you have to use in video games, sometimes, a lot of times, and I'm not good at math, so I made a little library that I could reuse. And after a few months, I felt super comfortable in my space of Canvas API developer. Then I went to lunch with another work colleague, and he was raving about a game engine that he started using. And he was telling me, Christina, this game engine does everything for you. It handles the input, it handles sprite animation, you don't have to worry about physics because it has a physics engine that you subscribe to. All of that work that you've been putting in, it does it for you. And he told me how he created a whole level without once opening the editor to write code. And I scoffed. I was like, where is the passion in programming? Like, come on, like I can do that already. Why would I want to go through that? And he kind of read through my bullshit and he said, that sounds really great. I'm glad for you that you can do that, but I just want to make video games. I just want to tell stories. And I thought about how, since the Space Invaders debacle, I hadn't made anything public since then. I had made lots of clones, I had made templates, I had made libraries, I put it all in packages, but not once did I actually put anything online. Not once did I make something that someone could actually play. And I started to wonder, am I kind of hiding in this refactoritis, this zone of comfort where I understand algorithms, I understand design patterns, I understand structure, let me focus on that and not have to expose myself and show someone something creative that I thought of from scratch, and then tell complete strangers, hey, could you critique my work? Could you tell me how awful or great it is? That was something I was very scared of. So I thought, okay, let me give this a try. By the way, the engine he was talking about is Unity, one of many game engines that exists. So this here was the first game that I made in Unity, aside from like the Flappy Bird clones that you follow on YouTube and stuff. I took a week off from work. I took holidays to work for a week on this. And it's basically a wholesome top-down shooter. I wanted to make a game about art block. I don't know if anyone's ever been through art block or likes drawing, but basically it's where you really want to draw paint and you just can't. You don't feel inspired, you draw for hours, it's rubbish. And I was going through art block at the time. I hadn't drawn for over a year. And I illustrated the whole thing myself, which was a big thing for me at the time. My daughter did the voice acting, so whenever you get hurt, you hear, eh, and that's my kid making those noises. And I just had a really great time making it. I'm super proud. It's up on itch.io on a public site. People can play it. I've gotten feedback from it. The code is abysmal. The code does not look good. It's not very beautiful. It's not using the best practices. It's not using the best patterns. But it's out there, and I learned so much from this experience. And a year later, it's still one of the things that I'm most proud of. So, a bit of a weird intro to this topic, I know, but when I say that I don't believe in design patterns, I don't really mean that. What I really mean is I don't believe design patterns will help you finish your game, okay? I don't know if you've seen stuff like this before. No matter what you're interested in, there's always going to be some article, some video that says that there's a better way of doing it, right? So 6 design patterns game devs need, top 7 design patterns every Unity game developer should know. 8, then there was 9, there was 10, there was 11, there's 12. If you go by that, it kind of seems like it's just never good enough, right? And first off, before I show you a couple of design patterns and their applications, I really want to say if you are here right now because you're interested in making games and you feel like the quality of your code is what's is the barrier to entering into making games, forget that, okay? You can make incredibly fun, interesting games without having incredibly beautiful, dynamic code, okay? That being said, even though I really, really try not to use best practices when I'm making games because I don't want to get stuck in that, I'm like, no, bad practices, public, all this stuff over here, static, oh my God, static stuff. It just so happens that naturally some design patterns emerged in my code out of necessity, right? Because I had the same problem over and over and over again. I really needed a solution. And then magically a design pattern emerged, and I was like, okay, I guess design patterns are good after all. So I'm here to talk about 2 of those cases where that has emerged. And those 2 are the observer and the state design pattern. Now, I'm not going to go into how these design patterns work like classically, because you could just, there's billions of tutorials of that online. I don't think that would be interesting. So I want to show you just kind of like an application of this to a very specific case within a mini game. So first off, before I go into these design patterns, I don't know how many people here have ever opened Unity before. Okay, a couple of hands in the air. Awesome, but not everyone. Okay, so I have to assume, obviously, that maybe not everyone had seen it. It's a little bit overwhelming. An engine that does so much for you also means that there's a lot of information that maybe you're not interested in. So there's 3 main things that I probably will mention many times, these 3 terms: your game objects, your components, and then your assets. An asset is a project file. So it could be a music file, it could be a sprite sheet, it could be programming scripts that you are creating. They're not necessarily included in the game per se, but they're definitely included in the project, and usually come externally. You drag them into the project. Now let's say you've dragged in a sprite sheet and you have a really cute little image that you want to use for your player. You drag this image into your game. Well, now this image is considered a game object. It's something that is actually being used in your game right now. The name game object is incredibly generic, right? What is a game object? Everything in a game is a game object. The music, the way you handle the keyboards, the UI that you see with your score and your health, the players, so many things. So how do you distinguish just text that's there in front of you, the score, and then a player that has behavior that can jump, that interacts? That's through components. So basically, a game object is kind of like an empty, bare bones object that only has a position in space and nothing more. And then you can drag a component onto your game object and say, I want this guy to be a sprite, so I'll drag a sprite renderer component. I want him to be animated, so I'll put an animator component. I want him to subscribe to the physics, so I'll put a rigid body component. And that's how you can kind of configure these different objects and make them more interesting. When you open the editor for the first time, boom, a lot of stuff going on here. And we have a simple 2D project. It would be even crazier if this was 3D. So down here at the bottom, this is at least how I have things organized. This is going to be my asset window, my project window. So these are where those files are I was telling you about. So when I drag in music files, when I drag in image files, they're all down here at the bottom, and they're not necessarily part of the game just yet. Then I can click on one of those and drag them to this window in the middle. This is considered the scene view. Now, a scene could be an entire level of your game, and only a small portion of that scene is actually visible, but you have everything else happening behind the scenes as well. So I start to drag, I drag this platform on here, I drag a person on here, and anything that you drag into your game will now appear on this side, the hierarchy. So I can have literally hundreds and hundreds of assets, files that I've put into my project. But in this case, I'm only using a few. I have a player, I have a grid. This grid in this case, it's just a bad name. It's this tile map that you see down here. It's the world. Canvas in this case represents the score and stuff like that, the UI elements that you see being drawn on top of the game. And then I have objects that I've created to manage the sound and also the keyboard controls. If you click on one of those game objects, like the player, then on this side over here, which is the inspector window, you can basically see what are those components that she added to this to make this a proper, more interesting game object. So the player has a box collider. This is basically an invisible box drawn around the image that lets it collide with other objects, right? Collision detection. Unity kind of you just draw a box and it's done. Rigid body 2D, this is what lets it ascribe to gravity. If you push something against it, it will fly away, so it already does that as well for you. And then I've added a script to give more behavior. Now I can have a lot more components than this. This is just a very simple version. If you open one of these components, you can see each component is made up of a lot of information. A sprite renderer, you can change the sprite, the color of the sprite. You can flip it horizontally or vertically. All of these things you can usually change in the inspector. So visually like this, drag stuff, click on stuff. But you can also access this information like a normal object in scripts when you're programming. So you can access it like an ordinary object. You can do sprite render dot sprite equals and then give it some new information. Anything you can change in the inspector, you can also change with code. I know this is kind of like, especially for someone who's never opened Unity, it's very like, what? But we have a lot of stuff to talk about. So hopefully this is just a generalized overview that will help you with what's coming next. Now, the observer. If you look up the observer design pattern, you're going to find amazing descriptions. But for me, when I use an observer, it's literally with the goal to decouple. I don't want files knowing each other too well. Why? Because I'm usually making a ton of experimentations. I'm thinking, I think I might want this feature. Let me add it. Oh, I changed my mind. I don't like this at all. And when I decide to delete that feature, I don't want to then have to dig through all the other files and see who is getting to know this health UI. God, where are all these null pointer exceptions? So using the observer kind of helps from removing those dependencies. Dependencies by themselves are not bad, but it was an issue that I was starting to face several times. So the example that we're going to see is we have this little guy. He lives in this world. He's going to hit the spikes. When he hits the spikes, a little sound's going to play. Oof. And the heart is going to decrease. When he hits it twice, the heart is empty, a game over screen is going to come up, and we're also going to get a different kind of message. So basically, he takes damage. We have 3 different things happening. Audio clip plays, maybe an animation happens, he maybe goes, or something like that, and then the UI image at the top will make a change. Player death, different audio is going to play, a different animation is going to trigger, and then we have this overlay, this game over message is going to show up. And I haven't included this here, but normally you'll also want to turn off certain things. You don't want the person to continue moving even though it's game over. You might want to reset some values. So there's lots of things that I want to do when some kind of condition is true. How could you normally approach this? How did I approach this many, many times? Well, I thought, well, the player is going to be the one that knows when he dies, right? He has health, 2. It decreases each time he gets hurt. When it's 0, he's going to trigger all of these things. And when triggering all of these things means he has a reference to the audio stuff, and he says, hey, audio stuff, do something, play a sound. So my player script, this is pseudocode, okay, none of this would compile. This player script would basically, if I've touched a hazard, health UI, let's change the image to something else, and half empty heart. Audio source, let's play a sound. Let's decrease my health. Animation, let's play the hurt animation. What's the issue with doing things this way? Well, like I was saying, what if I decide I don't like health hearts? It's too cutesy. I decide I want to do something else. I want to display your health maybe with a slider or something like that. I think that's cooler. I'll have to delete the UI, right? Which means that if I remove the UI, none of this is going to work. I'm going to have issues because now I don't have an object assigned to this reference. So I'm going to have to dig through who are all the files that knew the health UI that I'm now going to have to correct. So I figure, okay, the player is probably the one object that's not really going to be removed from my game. Every game needs to have a player. So why don't I flip the script? Why don't I say instead of the player needing to know everyone, why don't everyone know the player? So you could do this a different way. You could say, all right, audio manager, for instance, many times, he has a reference to the player, and he'll constantly ask, hey, did you take damage? Did you take damage? Did you take damage? Are you hurt? Are you okay? What's going on? Are you okay? Are you okay? Are you okay? If the player health is different from previous health check, then I'll play my sound. But this is also an issue. Every frame of this game, I'm constantly polling for data. I'm making checks, right? What happened? What happened? What happened? What happened? What happened? And it's not just the audio, it's everyone else. Half a dozen different components all asking, are you okay? Are you okay? Are you okay? Are you okay? And really, getting hurt should be a special event if you are a good gamer, right? You shouldn't be hurt that often during the gameplay. So really, ideally, what we want to happen is the player gets hurt, and we want them to kind of emit a special event saying, hey, I don't know if anyone's listening in, I just hurt myself. If you care, do something with that. And we want everyone else not to be listening to the player, but listening for the special event. And only when the event occurs, Does it do something instead of constantly checking? This is kind of the general idea of the observer, because I wasn't sure if everyone was aware of this design pattern. There's lots of different ways to implement this, very classical ways. I wanted to show you a particular way that I used. And I first got the idea that maybe I needed this when playing around with visual scripting, which is something that I've had to learn for a project that I'm on. And basically, it's writing code, but with boxes. Kind of like drag and drop style. I thought I was going to hate it at first. I actually don't hate it that much. I prefer to write, but still, it's cool. As you can see, I have an update, and I can connect it, and it all works with flow. It's a kind of tool that's really good for beginners to programming, or if you're working on a game, maybe with someone who's more into art and doesn't know coding that well, but they want to contribute in some way. A tool like this is really cool because they can easily connect some nodes to each other. So I was playing around with visual scripting and having these different graphs, and I had an issue where you don't really have references with graphs in visual scripting. They don't communicate the same way that classes do. So I was like, how do I invoke the method that's in the other graph? Oh, events are a thing. Awesome. So what's happening here, this is like the first steps, was I have a player graph, and basically I say, something's happened to me. There's an if or something like that back here. So if my health has reached 0, flowing through these boxes, we get over here and I say, I want to trigger a special event called play death. And the person who's listening to this event, in this case, was my sound manager. Then in my sound manager graph, he's just chilling. He's not doing any constant checks. He's just chilling. But he is subscribed to this custom event, play death. So when the player triggers it, basically this part becomes activated, and only when he triggers it. So he triggers it once. This gets activated, it flows into here, and he plays some kind of sound. This is not the observer pattern by itself, but it was kind of when I started thinking, oh, events. Events are a great way to help me in decoupling these different files. So when I came back to scripts, that's when I did what I'm going to show you here. So here we have our little dude. And I don't think it's going to work right now because obviously I've deleted a bunch of stuff for the demonstration. We're probably going to get some null pointers. But it should still run. Yeah. So he's going to hit this, and then we want to basically trigger those different events. So I'm a very visual person, right? I don't like to just write script. I also like being able to see things visually this way, drag items, see them in Inspector. Not everyone likes that, and there are ways to do what I'm going to show you with pure code, okay? But that's just me. This is what works for my workflow. Since I'm a visual person, I was playing around. This is something that already exists with buttons, for instance. I'm going to create a button. Boo, 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 button. Where'd he go? Okay. So a button has a special event here called onClick. And I can basically drag different functionalities that I want to run when you click on the button. It starts off empty. You can still click on it, just nothing will happen. And then in the inspector, you can make a list, basically, and drag, for instance, my sound manager. Come here. And then when you drag an object, it shows you all of the different components that are attached to that object. And I'll open up the script in a bit so you can see it. This is the script that I have. And I'm going to play the game over sound that I have. Get rid of this one. First, let me run it. Where's the sound? Oh, I'm connected to, yeah, hold on. I'll just come out of my speakers. It's fine. I think it should be good. Okay, you guys can hear that, right? So every time you click on the button, let me put it for the microphone. Okay. All right. And you can put a list of different things to run. So you could have this music, you could be turning things on and off. Basically, this is how buttons work. So it already has this system of events. So basically, I wanted to take this system of events, but put it from my own scripts. I wanted to have this same kind of functionality. I wanted to be able to say that the health UI, for instance, is waiting for some kind of special event and basically create a list of, and then he'll run this, and then he'll run this, and then he'll do this. So you can do that with, and this is specific to Unity. You can do this with Unity events and scriptable objects. All right. So just to show real quick, the player. So this bit of code here is basically what's going to check to see if my player hits something else. It's an on-collision enter, and that if is basically checking to see if I have hit a hazard layer, something that's being attached to like a special tag, basically. It's considered a hazard. If that happens, I want to trigger player getting hurt, and then I'll decrease my actual logical lives. And then if my lives has reached 0, then I'm going to trigger the player death. Now what is this player getting hurt and player death? Well, this is a class that I have. It's called game event. And it's basically just an event that gets triggered, and if someone else is listening to it, then something will run afterwards. By itself, it does absolutely nothing. And that's why right now, even though my game runs, you don't hear any sound, nothing's being turned on and off. My sound manager class basically has some clips, actual MP3s that have been passed over, and basically just has these two methods. Play hurt, which will play the hurt clip, and game over, which plays the game over clip. He does not have a reference to anyone else. He does not know who the player is. He knows nobody. Health. Health is basically just the image that he's displaying right now, and then a list of all the other images that I want to use. So a full heart, half heart, and an empty heart. And then he has a method taking damage, which basically just kind of iterates through that list of sprites. He also doesn't know anyone else. He's kind of self-contained. He's isolated. And then finally, I have a game event listener and game events. And this is the part where the observer pattern is coming into play. So this Unity event, this is what basically makes that thing on the inspector, the on-click, where you can press the plus and drag all different functionalities onto it. Okay? So this is what this part represents over here. When basically my object is activated for the first time, he subscribes to the event. Oh, I'm super interested in this event. Please let me know things from now on. If I turn off the component for some reason, then he'll be unsubscribed. He'll be removed from a list. And finally, he has a method that I can call that basically just calls whatever I drag in the inspector. So if I put that take damage sound, that's what's actually going to run. My game event is just something that's called a scriptable object. This is like super specific to Unity, and I didn't want to say anything that was too specific to Unity. But basically this is cool because it's what lets you treat data like it's just an ordinary project file. The thing with game objects, they live in the context of the scene. So if I have a level 1, and then I move to a level 2, all the other objects that were in level 1 are destroyed. They're gone. So imagine if one of those objects is keeping score. Oh, I had 50 points. When I move to the next scene, I'm back to 0. Now, there are ways about this. You can create like a singleton or something like that, something that will static, that stores that information forever. Scriptable objects also allow you to do this. Basically, this contains a list of everyone who wants to listen. And when I trigger that event, when the player says, on death, trigger the event, he's just going through the list, basically saying, audio source, you do something. Health UI, you do something. Level manager, you do something. That's basically what it's doing. And then the add listener and remove listener just takes it from the list and adds it to the list. How did this all come together? So, in Unity, I can create a project file, which is that game event. It's basically kind of like an empty object just to be used as a reference. And I'll call this on player death. And I'll create another. on player hurt. My player is going to have a reference to death, so you can trigger, and hurt, so you can trigger the event on that, which right now, come here, trackpad, all right, which right now won't do anything. Nothing is subscribed to it, but it also won't have an issue. Let me just run it real quick so we see. Hopefully there's no errors. Yeah, still good. So now what happens is, who did I want to react to the player getting hurt? Well, I wanted the sound to play, right? And then I also wanted the image to change. So I'll just go to those two different objects, my sound manager and the health. All right, let's say you are a listener. You care about a particular event. Which event does he care about right now? Oh, he's very interested in knowing when the player gets hurt. All right, what is he going to do when this event is triggered? Let's see. He'll just call one of his own methods, which is play hurt. And for instance, he really is also interested in the player death. And what he's going to do when the player dies? Well, he's also going to play one of his methods, play game over. Who else was interested? Health UI. So health UI, he's listening. In this case, the health wants to change every time I get hurt. So I'll just subscribe to hurt. I don't need to worry about death. And he's going to call one of his methods, which is take damage, which just changes the image. And then finally, game over UI. It starts off turned off. I can turn it on with this check mark over here. This is the whole enable and disabling thing. And what I'm going to do is going to say, you're going to listen for a special event, death in this case. And all he's going to do is he's going to turn the container on. Active. And fingers crossed. Oh, it never gets better, guys. If any of you are wondering, oh, will I ever be concerned if this is going to work? No, it's always a gamble. Yeah. Okay, so it's working. Everything's connected, right? Now, cool beans. You made an overcomplicated way of doing something that I could have done by just having references in my player script. What's the big deal? What do I really gain from this, right? Well, the cool thing, in my case, as someone who creates games in a short amount of time, I didn't mention this before, but I also now participate in a lot of game jams. So it's literally like you have a weekend to get something done. I'm doing a lot of trial and error, right? Trying something, I don't like it, let me take it away. So the cool thing with this is I decided I don't like those hearts. They're annoying me. Or the sound. I'm playtesting this so many times and I'm tired of hearing this sound. Let me just turn it off. Now, removing something normally will have a big effect, right? Anyone that needs to know that object is going to have issues. But since they don't technically know each other, I can turn them off. And everything else still works. I can decide that I'm tired of the health, and I can disable it. And everything will still work because they're not actually connected to each other. Health doesn't know who the player is. Another advantage with the health not being tied specifically to the player is now I can create a little goblin, and he can also have a health bar. And I can reuse the same script for different objects, and because they're not tied to each other, it's fine, it works just great. So I really like the observer pattern, the principle of decoupling, of asking someone to run something only when it needs to, because it kind of helps me divide responsibility. Because now I'm making sure that they don't know each other, and I'm imagining, ooh, I could reuse this script for something else, then I really kind of focus on making scripts that do one single thing at a time. They're really clean, they're really small, they do very specific things. It just changes the way that I've decided to approach my work. Now, Oh, and this was just kind of like a visual aid on what's going on. So the player triggers the event on this object, on player death. And when that happens, he's iterating, going through a list, basically, of all of the guys that has subscribed to this event and telling them to do some kind of work. What about the state pattern? So this is one where I think, it's one of those patterns where in theory I think it's really easy to understand. And you can achieve this with just a simple switch case. And a lot of times you can stay with a switch case. Don't overcomplicate things just because you can, right? If you can keep it simple, keep it simple. And then it's one of those things where I feel at least that it starts to get complex really, really quickly, okay? And I'm going to show you basically like a mid-tier of the state pattern. So for this example, we're going to have this situation. Our little player has left the green fields of the first level, and he's found himself in a cavern, okay? And he's being attacked by this bat. In the beginning, the bat's just kind of patrolling around to these 3 invisible positions that we're not seeing. So it kind of just goes in like a triangle formation. And then after 10 seconds, he decides he's going to start chasing the player around the screen. He follows the player wherever he goes. And then after that, he'll move to the center of the screen where you could have an imaginary machine gun or a turret or something, and basically he starts shooting projectiles at the player. Now, you see this a lot in games, right? These kind of creatures that have different behaviors. You also see stuff like this a lot in boss fights, right? Have you ever done a boss fight where he reaches 50% and suddenly he's way stronger now? Like he brings out the big guns, he's like really mad, he moves on to the next phase, or the worst still, when they get to 0 and then they come back, right? For a vengeance, that's the worst. You think you beat them and then they come back even more. So basically you can imagine that this bat is going through at least 3 different phases, or you can call them states. One where he is patrolling, it's an action, right? Then he's into chasing, and then he's into shooting. And he's never really in one of these 2 at the same time. He's either in one or the other. And also there's kind of a clear order in this case. He goes from patrolling to chasing to shooting. And then maybe he could go from shooting back to chasing, or from shooting back to patrolling. In my case, he kind of just stays there like a boss. So one way that you can do this, perfectly valid way to do this, and this is also, before anyone chides me, this is wrong. I know it should be else ifs, not ifs, because otherwise this would just kind of run through it all. But basically you could have in your update function, which runs at every frame of the game, a timer. That's the condition I decided to do to make him change. And there's a bunch of booleans up at the top, right? Basically, I'm decreasing the timer, and then I say when the timer has reached 0, let's reset the timer again, so it goes back to 10, 9, 8, 7, 6, blah, blah, blahs. And was I currently patrolling? Oh, no, not anymore. I'm not patrolling, I'm chasing. Oh, was I chasing? No, not anymore. I'm now moving to the center. Oh, am I currently shooting? Now I go back to patrolling. The moving to center isn't here because in that case it's not based on a timer. You change from going to the center to shooting because you've reached the middle. So this is the part where, how do I know I'm supposed to go to the next phase? And then somewhere else in your code, within this update, you could then have more ifs, where you basically see, all right, which phase am I in right now? And then you put all of the logic of that phase within that if. So if I'm patrolling, move between the 3 points on the map. If I'm chasing, let me go after his position. If I'm moving to the center and I've reached the destination, cool. If I'm shooting, and basically you have all of your code there. Perfectly fine way of doing things, okay? It's just simple, it's Booleans. What is the issue with doing things this way? Well, when you're dealing with Booleans, not only do you have to make, in this case, I have to make sure that I turn them off, right? Because I don't want him to both be patrolling and chasing at the same time. So I kind of have to do this whole toggle off, toggle on, toggle off, toggle on thing. And that can get messy real quick. Plus, I can also accidentally equal a Boolean to an expression somewhere else in my code, and then it will completely mess up the order. I have a lot of state at the very top, minimum. This is a very simple sequence of actions. If I have even more, then I have even more of this state going on. So I didn't think that this was a big issue for a while. I could tell that it was probably not great. I could tell, yeah, I know there's better ways to do this, but I have 2 days to make this game, let's go on. And in Unity, you play around with, sometimes, this animator window. That's what we have over here. So imagine you have animations, which are sprite sheets, and you have a very finite amount of animations. You don't have billions and billions of animations on a little character. He's idle, and then he'll run. Sometimes he'll jump. Maybe he'll have a different special animation for falling. Maybe he has an attack animation. That's about it. It's a small amount. So in the animator window, these boxes represent some animation that's attached to my player. Idle represents 6 frames that are looping over and over again. And then I can connect these different animations through some kind of condition. So I can say, for instance, it doesn't make sense to go from idle to diving, because I shouldn't be able to dive into the ground. But I can go from idle to jumping, or I can go from idle to crouching. So you basically decide, how am I going to connect these different things together? Okay, when does idle go into crouch? You create this flow, and then you can click on any one of these arrows and basically add your conditions. You can say, well, he's going to go from idle to crouching because somebody pressed down on the key. Or he's going to go from idle to jumping because someone pressed the space bar. And then maybe while he's in the air, if you press down, that's when he dives. So the same key could be used for 2 different actions depending on the phase he's in. So this is a state machine. Basically, you have a finite amount of states, possible phases that he can be in, and you go from one phase to the next based on some kind of condition or some kind of trigger. And you can do this a lot by just planning it out on paper. What are the actions that you want your player to have? So in my case, I want my guy to patrol, and the condition to go from patrolling to chasing would be when the timer ends. And then this was just me imagining, maybe he's chasing forever, indefinitely. But once I've hit him a few times and he's reached half health, that's when he decides, all right, I'm going to go to get the machine gun. Now I'm mad. He goes from moving to the middle to shooting because he's reached his target position. And then maybe he's run out of bullets and he goes back to patrolling or something like that. Or he could even go from shooting back to chasing. This doesn't have to be a closed loop. It can be in whatever order you want it to be. So if this is how I can envision how I want these actions to go, then anyone who's playing around with OP knows that, well, why don't I just represent this as a bunch of classes? Each particular phase is its own file, basically. And I kind of hide those details within that file. That's the general idea of the state. Now, before I reach that, going and creating new files, like I was saying, you can do this with a simple switch. You can create N and num, patrol, chase, move, shoot. These are the possible states that I'm in. I have a reference to the current state that I'm in. I want to start off patrolling. And then I just have a switch case, where basically I see, what is my current state? Am I patrolling? If so, let me put all the logic to patrolling, and then I have the condition that switches to the next state. Oh, okay, now the current state is chasing. And then you have all of the cases for that. And this is, yet again, I'm telling you guys, this is fine. This is a great way to program. This is excellent. Helps you get your game out, right? But maybe you want to play around with something a little stronger. Maybe you want to be able to easily change the order in which he does things. Maybe you want to be able to reuse some of these actions for your goblins as well. A goblin that just patrols and shoots, doesn't chase. So having this all here in this file isn't going to help you do that. That's when I want to extract things to their own separate files. So I think, all right, I'm going to create a file called patrol state, chase state, attack state, and move state, but he's not here. Let's see these guys. All right, the namings of these are not ideal. I call this state machine, but in reality, this is just my bat. Okay? It would be my bat controller, bat script, bat whatever, okay? So my bat has a reference to some enemy state. The idea is you create an interface or something that basically represents what these states are, and then you have classes that actually implement those interfaces, or you could create it as an abstract class. In my case, I created it as an abstract class. Not sure why. So I basically say any state, whether it's patrolling, whether it's shooting, whether it's chasing, has these three methods at least. I can do the actions. This is what's actually going to be called every frame. Okay, it's what I want to be constantly doing. I have a method that gets called once when I go to that state for the first time. And it might be just doing things like setting your properties or resetting some timer or something like that. And then I have a transition state. And basically this checks a condition and gives you what is the next one, who's next. And this could be the chase, this could be the patrol, this could be whatever. Then I have a class for every specific state. So chase, pretty simple. Who's my target? Transform is basically how you refer to the position of something in Unity. So who's my target? I want to do something during 10 seconds. I'm going to receive that information from my state machine. Update is just moving towards the target, basically. And then transition state is going to check to see, have we reached 0 in our timer? If so, then I know who the next state is going to be. I go from, in this case, chasing the player to moving to the center. Otherwise, if we haven't quite reached that condition yet, then I just say, oh, the current state is me still. I'm still going to do some action on the next turn. And you do that, you basically create one for everything. So what is moving to the center? That's also just moving towards the center of the map. What is patrolling? This is going to have a list of different positions that are invisible. And he basically is going to just perform a random where he picks one of those 3 invisible points at random and then moves towards there. And shooting is also going to shoot at a particular target. In my case, shooting has a cooldown effect. So like, how often are we shooting these bullets? Is it every second, every 2 seconds, every second and a half? How many bullets? Oh, I don't have that here. I don't have the how many bullets thing just yet. But how hard it's going to be shooting, and also has a cooldown timer in my case. So you create these different classes, and then the way that it looks in your main class, basically like your bat class or whatever, is in the beginning, you say, what is the first state that I want my bat to be in? Patrolling. And then I tell him, let's enter the state. I give him a reference to myself in case he needs any data, some information. And then on update, I just say, whoever is the current state, I don't know who that is right now, but whoever it is, run. Do something. Are we currently patrolling? We're moving between those dots. Are we shooting? We're then shooting bullets towards the guy. And then each time I'm asking, all right, and who is the next state? And sometimes he'll say, there is no next state, it's still me. And sometimes he'll say, ooh, we reached a certain condition. Now it's going to be chasing. Now it's going to be whatever. The way that this is going to look on the scene, all right, got a little bat. He's chasing us around. Well, first he's patrolling. Are you going to chase now? Yeah, now he's chasing. Leave me alone. For how long? I don't know. Okay, now he goes to the center. He's going to, in this case, he shoots indefinitely. This is basically the final phase. And there's no way for me to attack him, so this will definitely go on forever. Okay, but right now, it just kind of seems like I complicated things for the sake of complicating things. I don't really, in this case, have a very big advantage. Yes, the main file was very, very clean. It just says update whoever you are. But was it really worth switching from a switch case, creating all of these different classes? Currently, I would say maybe not. But the cool thing with creating them as separate classes is now you can add extra functionality to them, right? So the main goal that I had before is sometimes I want to switch the order in which this happens. I don't want him always to start patrolling and then chasing. Maybe I want to create a different bat that uses the same ideas, but he starts chasing. The issue that I have is since patrol is hard-coded to always return chase, and chase is hard-coded to always return center, I can't really switch things around. I can't make this cute and configurable. So why don't I just tell each state to know who the next one is? That's the only change that I really need to make. Instead of him being hard-coded and saying, the next one is going to be chasing, how about he receive that as a reference? And he just says, whoever's next, it's this guy. So in the improved version of this, and I began with I, though in reality that makes it seem like they're interfaces, so you shouldn't do that. Where are they? I enemy state. I just added a new method to it. I just said, and when you are instantiated, you will get to know who the next one is. You don't start off by knowing who the next one is just yet. And then in each particular one, the logic is pretty much the same. But now instead of them returning someone specific, they just say, and the next one is whoever next state is. And just that little change has suddenly given me way more control and way more possibilities in my game. So I say, let me show you the state machine that's a bit different. Whoa, 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 whoa. Get out of here, sir. Too much information. Okay. So I say basically, give me the list of possible states that you want me to play. In this case, the order in which I pass them is important. Whatever I drag in the first position, that's going to run first. I give it the list of states. I also added this Boolean because sometimes I wanted them to go back to whatever the first state was. I wanted them to loop back to the beginning rather than be stuck shooting. So if I was doing like a boss fight, I wouldn't loop back to the beginning because then it would never end. But if I'm just doing like NPCs that are patrolling and then do something every so often, then I could use something like this. Basically what happens is, this could be in a different file, it doesn't need to be here, but I receive an enum, and I basically just return the instance that is mapped to that enum, its version. And when this file runs for the first time, I just loop through that list that was given to me. I create the objects that are needed, and I say, whoever was previous, here's your next. And I basically just set next to all of them. Which means that in the inspector, the update hasn't really changed. I still just say, whoever's the current state, run. I ask the state, hey, have you changed? Is there a new one? Because if so, let me update that reference. And then if he has in fact changed, then I will make sure to initialize him. So in the project, that's where it gets a bit more interesting. Fly enemy. Where are ya? Little bat. So now I basically give it a list of states that I want it to be in. And I can change the order. For instance, I want him to maybe chase me first, and then he'll patrol, then he'll move to the center, and he'll shoot. And I said, I want him to actually be looping this time, so he goes from shooting back to chasing. And let's first see if this works. Oh, Lord. All right, so he's chasing me first off. Okay, I should have made it less than 10 seconds. Now he's back to patrolling randomly between 3 dots. Now he's moving to the center, he's shooting me a few times, and now he's back to chasing. And if I want to swap the order, I'm not going to run it the whole time, we'll just quickly see if he starts off patrolling at least. Now he starts off patrolling. So now I can have, theoretically, 2 bats, one that starts off patrolling and then chases, one that starts off chasing and then patrolling. I could actually create a whole new dude that only patrols and every so often shoots, so I'll do that in this case. I can reuse these same actions for completely different objects because they are now separated. And that's basically the advantage of separating things, is reusing stuff. But until you reach that point where that is necessary, don't just stick design patterns in your code for the sake of it, right? Make mistakes, write terrible code, write things the wrong way, discover that, oh, I'm actually having this issue several times, and then figure out what is the solution to this issue. Oh, it actually turns out to have a name. Okay, now we'll officialize it and figure out what's the best way to do this. So these were the two main ones that I find that has helped me actually with creating games really, really quickly. The thing is, obviously, if I wanted to create really complex AI, this isn't flexible enough. It's just kind of like a starting point. Like if I had input, imagine if the bat is patrolling and it's like pitch black. Maybe you're playing the bat, you're actually the enemy in this game. The bat's patrolling and it's pitch black and you hold the space bar and he kind of emits a sonar, right? And it opens up a circle and you can kind of see the light. And oh, now you've seen the player within that light, that's when you start chasing, right? So the transitions are different. Well, now it's going to look a little bit more complex, the different states that he can be in. And spacebar maybe sometimes means shooting, but other times it means doing the sonar, so you have to check what state you're in before you use the spacebar in that way. So again, this can also quickly get out of hands. And if you really need something more complex than this, then there are other ways of doing it. The state is not the solution. I know this kind of seems like I'm referring to this talk 1 year later, but this is actually 1 year later after I started playing around in Unity. What have I learned? So this is still true, right? I still have these, I'm made up of more than just liking making games. I'm still a teacher, a mom, a digital artist, and a wannabe game developer. In reality, they don't have equal footing in my life. Some things are way more important to me than others. So game development is really just such a small, tiny portion of my life. And yet, within the year, I've managed to make quite a few, like half a dozen mini games that I'm really happy with from start to end, that are public, that are all on my itch.io, that have received critique and things to improve. And I'm really, really happy about that. And how did this start happening? Well, it's when I started letting go of the perfectionism, right? And just being like, all right, let me just tell stories, and I'm sure I'm going to learn along the way. So this is my own version of those YouTube video titles and the LinkedIn articles, top 5 things you should be doing now if you want to be making games, in my opinion. And the first one is join a game jam. If you want to make games, join a game jam. There are thousands of them. The one that I participate in happens every 2 weeks. It's actually going to start this Friday. And what happens is they release the theme a week before, but you only know the limitation on the day. It's very hectic because you start Friday, you have to give it in on Sunday, but you really leave your ego at the door because you're like, I don't have time for perfectionism. I just have to get something out. And then you go through a week of ranking where everyone ranks you, and you actually are either in first place or second or third, but the critique, the criticism you get, the feedback is really, really incredible. So this is from a site called Indie Game Jams, and this is showing you what's happening in the next 2 weeks. So what game jams exist within the next 2 weeks. So you have a lot of choice. There's one called 1 Hour Game Jam. That's very interesting. When you decide to make a mini game, if you want to participate in these game jams, I really advise just picking one mechanic and then enhance the gameplay through that one mechanic. Pick something that you really want to learn about, and then try and think, how can I make this whole game revolve around that? For instance, this Friday, I decided to pick a mechanic, which is I want to do soft body physics, because I want to kind of do like jelly stuff. And I want to figure out, all right, if you're a jelly, then how would the level be fun, right? Maybe if you have lots of vertical drops and you can see the jelly flopping over itself. So pick a particular thing and think about how you can design the level around that. This is the most boring, but also the most important, which is be organized, guys. Whether you use pen and paper, Trello, Notion, Obsidian, whatever, a to-do list, breaking down the steps of the game that you want to make into smaller tasks, and then prioritizing which ones are absolutely essential and which ones need to get out, incredibly important. And then revise this list every single day. At the end of the day, I sit down, I look at the to-do list, I'm like, all right, I'm never going to get around to that, that's gone. What do I need to work on tomorrow? This, and that. getting feedback. And when I say getting feedback, it's not just your friend being like, cool, good job, looks really nice. Or even worse is them saying, but they're not actually giving some information. Getting feedback and actually you giving it too will really help you understand what makes a game fun. So this was the first game jam that I participated in. I chickened out. I basically just did a whack-a-mole clone, basically, with a cute frog on top of it. And the amount of comments that I got on the game was staggering. And they were all from other developers that were doing the game jam as well. And the great thing is, even though they were super nice, they always had something that I could improve, right? Maybe the frog is moving too fast. Maybe you put a few seconds of stop animation. There were some signaling issues. Your frog looked pained, so I thought I was supposed to avoid them. And there was a lot. And all of the information that they gave me was essential for the next game that I decided to make. And then you also feel compelled to give this same kind of helpful feedback to other people. And I really think this is what skyrockets your capabilities when it comes to making games. And finally, I think you should forget the design patterns for now, at least. And yeah, that's it. We're at the end. I'm done. Whew, 1 hour, done. All right. I also just put, if of course you're here, you love design patterns, right? Of course. This is like the Bible of design patterns in gaming. It's like really, really great. You can access the site. It's just called, if you look up game programming patterns, you have access to this. Basically, this is a guy who worked at Electronic Arts for like 10 years, and he decided to write a book on all the design patterns he found most essential. And the really cool thing is he made a really cool web page that's really easy to read, and it's 100% free. You can download the PDF for free. He made it free. If you want, you can pay towards it, but it's also completely free. And then this article in particular is what basically opened my eyes to scriptable objects. So if you are using Unity and you want to read something more specific to Unity, then I also recommend this article. And that's my name. All right, thank you. I don't know, where are you? I don't know if we, like, what happens next? Do we have time for questions or like 10 minutes, right? Yeah, then we got to go, okay. So.
If you have any questions, you can ask. Do you have any questions, anything you want to ask?
Do you make your own designs for every game that you develop?
So if I make my own designs, what do you mean by that? Like the art or? Yeah, because for me it's also kind of a way to practice art, but you don't have to make your own art to make really fun games. There's a ton of legitimately free assets online, not stolen assets, but legitimately free assets that you can get, especially on this site that I've been talking about a lot, itch.io. And they come with sprite sheets, they're all fully animated, so if that's not something that you're comfortable with, that doesn't mean that you're not going to be able to make really nice looking games. But yeah, I make the art for my games. Cool. Oh.
How many people do you think it's too many to work on a game? I know it might depend on the size of the game.
Yeah, I was going to say, so how many people make sense to work on a game? Again, my experience is very much in a small scope, right? The longest time that I've worked in a game is a month, and I've worked with other people, but generally speaking, it's by myself. So the answer to that question is really going to depend on like how big of a game are we talking about. If it's Baldur's Gate 3, then I guess it's a lot of people. But you know, if you're making a game for a hobby, if it's 2D, I guess it depends. Like, imagine you're making a 3D game, but you're not comfortable with the actual 3D aspect of it, like the modeling stuff. Then maybe you could have a friend join your team who's really, really good at 3D modeling. So the amount of people on your team kind of depends on your needs. I have no personal opinion on like what is too much, right? How many?
Because I think that when the team is quite big, or at least medium, it might be important to actually add some patterns in order so everyone can understand how they should work.
Yeah, like the biggest advantage I think to design patterns is not so much the effect they have on the code, but more the effect they have on a conversation. For you to be able to introduce someone who's new and be able to say, oh, we implemented this with a factory. Like everyone knows what a factory is, so even without needing to look at the code, they now are able to like have a consensus on how it works. So yeah, I know it seems like I'm bashing design patterns, but I love design patterns. I think they're really, really important. I just also feel like, especially programmers, we kind of get in our own heads like a lot, and making games is such a creative process, and anything that's creative is also incredibly terrifying, right? Because it's very much exposing yourself. And so I kind of just wanted to say, well, if anyone's getting trapped in this loop of making sure something's perfect and perfectionism and refactorism, break out of that. Don't worry about making ugly code. That's fine. But of course, yeah, design patterns are really essential to making something scale well, right? Thank you for asking. Any more questions? No?